All right, let's move to Chapter 7, and we're going to look at solving systems of equations. So far, our problems have either involved a function of one variable or a single equation in two variables. Many problems in science, business, and engineering involve two or more equations in two or more variables. To solve such problems, we need to find systems of equations. So we're going to consider first two equations and two variables. Now hopefully that looks familiar to you. Let's recall something. The solution of a single equation in two variables is an infinite set of ordered pairs. However, quite often we would like to have only a single solution rather than an infinite number. In this section, we're going to study two methods for solving a system of equations. One is the method of substitution, the other is the method of graphing. Substitution is very good. Graphing is only as good as you can graph. Calculators, though, have made that much easier. Right? For example, let's suppose we've got minus 2/3 x plus 2, and we store that in y1 of x. In other words, we're storing both equations here so that we can easily go to the y equals screen, and we're going to plot these equations. So we're going to zoom standard. Here they go. Notice they're going to intersect each other in one point, and of course our solution is only as good as we can read that point. Let's check out another example. Let's suppose that we have the equation x minus 7, and we store it in y1 of x. And let's store x plus 3 in y2 of x. Hey, look at here. We've got two equations. Notice they have the same slope, but they've got different y-intercepts. Can you guess what's going to happen as we plot these? If you guessed that these two were parallel, and hence we have no solutions, you were exactly right. No solution, the lines are parallel, they had the same slope. However, let's look at our third scenario, and we have to go to our maple to make this graph. The calculator, you're really not going to be able to see it. So we're going to do what is called implicit plot, and we're going to plot y equals x minus 2 and 2y equals 2x minus 4. Now hopefully you can see immediately that these two equations have the same slope and y-intercept. And you say, why are you graphing them? Well, I want you to see that when you have that kind of a system, what's going to happen is that it's basically going to graph as one equation. We often call these coincidental lines. And you're going to see when this plots that it's sort of like the red line and the blue line overlapped each other. Let's fix it so that we can see it in the screen better. And then, yes, that's better. We can see it happening there. And then we're going to notice here that we have since the equations have the same slope and y-intercept, only one line plots, and we have an infinite number of solutions.